All right, so let's start our problem-solving session. Uh, are there any questions from you guys?
So I answered one of your daily answers about closure for intersection.
For NFAs?
Yes.
Okay.
Can you go through that?
Oh boy. So here's the thing. For NFAs, when we did product construction for DFAs, we relied on the fact that it's correct because there's only one computation through the machine, right? There's only one computation through the machine. Whereas with NFAs, it's a lot harder because we may have multiple transitions on the same symbol, and we may have epsilon transitions. So let's see if I remember it. Okay. It'd be a lot to do right here, but I can post an answer on Piazza if needed. So I'll just give you an intuitive idea. The idea is, well, we'll do the product of the states just like with DFAs, no difference. But the thing that we'll handle differently is not only the possibility of multiple transitions, but with epsilon transitions as well. So for the transitions that do actually read something, so not the epsilon transitions, what we'll do is we'll just do the construction just generalized a little bit. And the idea is you will figure out what you could have done in the first NFA and what you could have done in the second NFA and go to those states in the product. Whereas for epsilon, well, I have a choice of not taking an epsilon transition, so we'll do exactly the same thing, but we'll also include the original states that we were in. Okay, I'll post an answer about it.
Okay.
Yeah, it's a lot of formal writing, but that's the intuitive idea. It's almost exactly the same thing as product construction, but you need to think about how do you handle multiple transitions and the fact that epsilon transitions we don't have to take. So for epsilon, we just include the states you were already in anyway. So that's the idea. Other questions? Yeah.
During class today, you mentioned that, hang on, let me pull up the thing that I was kind of confused on. Wait a second, it was the third thing in regular expression of FA. It was if R equals the empty set, and it was just, it goes into a not final state. Is that because there's nothing that can be final for that?
Yeah.
It was like just
So remember, empty set is just it looks like a character, but it is a regular expression here. So we wanted an NFA that had language empty. And there are many NFAs that happen to have empty language. That's a really simple one.
okay, and language empty means it doesn't have a final state then?
It automatically doesn't have a final state. Yeah, that's reachable. Yeah.
Okay.
But I could have had other transitions on this or whatever, but I don't know what the alphabet is, so I can't assume that. So I just because it's an NFA, I don't need any transitions at all. So I just made a single state thing that doesn't have any transitions, doesn't accept.
Okay.
Yeah. Other questions? Any other things you're confused about? Anything that you want to, any problems that you want to look over? What?
Is there any way that we could get problems that are similar to level 1 problems to learn them, so that we can sort of see like the train of thought that we're supposed to have?
What example problem from the homework are you thinking of? Problem set 0. I'm trying to think which problem would be good to talk about without giving the answer. Well, the good thing is that you guys, I won't be able to upload this by tonight, so no one will be able to see the video but you. So. Yeah. 3 is not supposed to be a hard problem, comparatively. It's not. It's a lot easier than you think. So, so we're gonna define. So I'm gonna do a similar type problem and not work the entire solution, but this is the idea. As follows. 1, 0 is an L, and for any x in L, x 1, 0, x is an L. And then prove that every x in L has equal number of zeros and ones. Well, it seems pretty obvious that it is true because actually let's switch it up. Let's instead of 1, 0 here, let's make it 0, 1. Well, why is it intuitively true?
Because your what I would call your building block, whatever your x,
The
so
big-
one x has equal amounts, and then
Yeah.
the only option is to choose to add in contain equal amounts.
Right. So 1, 0 has an equal number of ones and zeros. So I think someone's trying to get in. Has an equal number of ones and zeros. And if we assume that x has an equal number of ones and zeros, then if I put 2 copies in there, it has the same number of zeros and ones. Then if I add a 0 and 1 in there, then that doesn't change the fact that it has an equal number of ones and zeros. So let's see. So define, so formally, define trying to not give it away. Whatever. Well, let's see. So the idea is let's apply our definition of this language L in the same way, but in a formal way for counting the number. Well, if it's the base case, then we're all good. So the number, no. Okay, no, that's fine. So number of zeros in W, well, so this is, yeah. So these definitions are for any arbitrary string W and not for any string in L, right? So this is just for any string. Well, what is a easy string that we know the number of zeros of instantly? Yeah, empty string. And how many does it have? 0, if W is equal to the empty string. Well, so if it isn't empty, what does the first character have to be? Either a 0 or a 1. So there are 2 cases. Well, 0 followed by some other string, right? Equals 0x. And then the other case if W equals not 0x, 1x. And x is in 0, 1 star in both cases. For the second case, how do I find out how many zeros W has? Yes. So it's 1 plus the number of zeros in x. And then for the third case it is, don't take pictures, please. how many zeros are in X for the third case?
Just the
Number of zeros in X. Yeah, this is not W. Yeah, this is copyrighted stuff and by me, and yeah, don't take pictures without my permission. So that's a formal definition of number of zeros in W. And then now you just need to figure out what is formal definition of concatenation, and then what is the formal definition of how strings are in here. So, well, here we know that the number of zeros is equal to in 1 0 equals the number of ones in 1 0, and it's equal to 1. So the base case is correct. And then now you have to inductively prove that the second case holds. So you assume by induction that X has an equal number of ones and zeros, whatever that number may be. So you have to say it's like n or whatever. Then you have to define for concatenation, if I tack on a 0, that changes the number of zeros by 1. Then if I tack on a 1, it changes the number by 1. And then you have to inductively prove it. Okay? So this is not supposed to be hard, right? You just formally define it in terms of a base case and inductively. Okay? Any questions about that? Yeah.
I'm still hardcore struggling and trying to understand how to like do that next step. Like, because for me, I'm thinking.
Is that true, or are you trying to prod answers from me?
No, it's because to me,
No, it's
like,
fine.
the inductive proofs are like mappy, right? Like,
Yeah.
I have like the equation. I don't get how to do this without any equation. You know what I mean? Well, yeah, because like almost
I'll do an inductive proof.
yeah, and I don't.
Well, it is a sum here. Yeah, that's what will be true here. It's the same thing. You'll be adding 4 numbers together.
Like, I was trying to tell myself, like, this is the point that I got to, and then I was like, yeah, where do you go?
So you have to formally define, if I concatenate 2 strings, I add the number of zeros in each. So if I want to count the number of zeros, so you have to prove that if W equals XY, then the number of zeros in W is the number of zeros in X plus the number of zeros in Y. Then once you can prove that, then once we have that inductive case, then if we have, so assume X in an L has number of zeros in X equal number of ones in X, then does X, how did I do it? 0, 1x have number of zeros in this thing equal to the number of ones in this thing. And that seems intuitively true. So you just have to just do 2 different sums. I'm not going to give the whole proof. I'm literally like 99% of the way there. Like, I'm not even kidding. I'm not going to give the whole proof. But it's very, very close to this. Okay? Other questions? Or more about this? Yeah, 243, they're not teaching it well. I know. I'm very sure.
Dude, okay. I took Math 300 and logic and computer science, and I still don't know how to do this. Like, I don't know what else I could could possibly take you to prepare?
It's been too long, I think, for 243, because that's first semester sophomore year. Second year.
Yeah, I took that like a year ago.
Yeah.
Just got a side question. I know that there's the option of writing I don't know, gives you 20%.
Mhm.
Then it also stated that would it be better to work on a train of thought that might end up being incorrect as opposed to just writing I don't know? Or is it, you know what I mean? Like, or is if you put in a lot of work and it's like, oh, well,
If you were in my position, what do you think I would do?
probably give more credit to trying.
Yeah. Yeah, it's so
It's only
in life you'll never get everything 100% right. So if you know you can't do something, what will you do? Try. And how do you demonstrate that you tried to me, or whoever's reading your thing? Yeah, let's show your work. Tell me the ideas. The ideas are more important than the actual answer. Okay.
That was going to be my question. So if I know what I want to say, but I don't know how to formally write it, is that good
It's
enough
better
to
than
write
nothing.
what I think is happening?
Yeah, it's better than actually writing nothing or I don't know or whatever.
So
Yeah.
basically only for like bullshitting things, but I kind of you get my point though.
No, I actually don't know. Sorry.
Like if we like absolutely don't know. Like,
Yeah. Yeah, you're better off doing. I mean, this is prereq stuff. You should know this, but if you actually, I know that there's a huge variability in what people teach in 243. I wish it was different, but if I were in charge of it, but I'm not. But if you truly don't know, yeah, that's always an out.
But
Yeah.
if we try it all, we're most likely gonna get at least 20%.
If you wrote the words "I don't know," you'll get 20. But I can't guarantee anything because I'm not the grader.
Right.
He drew a picture and
Yeah. If you draw pictures of smiley faces,
I don't know.
you may get sympathy points.
So they get it.
Yeah, good card. Yeah.
You've had a couple variations on this question, and I haven't gotten an answer that works for me.
Okay.
It's clear that not all of us got all of the prereqs
Yeah.
from our prereqs that we need.
Mhm.
Can you give us a resource where we can go learn it tonight?
So,
In the next several days, whatever.
I mentioned this-
Basically, we don't have this knowledge and we need it.
Yeah.
Can you recommend how we can get it?
I mentioned this at the beginning of class. What's one resource?
Chapter 0.
Chapter 0 of CSE355 is a good one. CLRS for the main programming paradigms, greedy and dynamic programming. Does anyone know who Jeff Erickson is? Yeah, so this person is a professor of computer science at he's a professor of computer science at University of Illinois, Urbana-Champaign, and he wrote this incredibly awesome set of lecture notes for algorithms and for models of computation, like the thing that we're studying now. So that resource is a great resource. But it covers the same thing, essentially.
Like, I read chapter 0, and I understand it, and it all makes sense, but there's a difference between understanding what
Yeah.
you just read and applying it.
Yeah,
So how do we fill in the gap from understanding to being able to apply it to the problem?
so what's an example one?
Any of the problems on the problem set. I literally can do 1A, that's it.
Yeah, I think the point is that we all like understand it when you're up here telling us, we're like, cool, that makes so much sense, but how do
Yeah.
we get to the point of being like, oh, I know what I'm talking about, you know?
Working examples is my number one. Yes, so the resource I just mentioned, that has a lot of good proofs in it that I highly recommend it for this type of thing. Working examples really helps. Watching my recitation videos from this past, so this isn't true to problem set 0, but for all the other things, I did a series of recitations for last semester. They're on Blackboard if you want to watch those. So I've heard they're really, really helpful for a lot of people. So take a look at those. I can't really recommend a resource unless it's a specific thing. What, sorry?
I said those previous recitation videos are really good.
Thanks.
So
Yeah.
The stuff that we're failing at problem set 0, is that super important going forward? Because I mean, I feel like I'm following everything that you're talking about in class.
Yeah.
If we are not at all understanding
Everything?
problem set 0, like 0 of it, are we gonna be dead going forward?
Probably not, because the so it's just establishing that you understand the prereqs, but being able to prove things by induction formally, working with graphs only a little bit. Those types of things are the most important thing. Yeah.
I looked ahead at problem set 1, and that's much more directly related to what
Yeah.
we're talking about.
Yeah. So the only thing that you shouldn't have known to do problem set 1 was NFA to DFA, but we covered that today. So you should all be all set for problem set 1.
So
Yeah.
basically, we could just take this as our 5 points that we're gonna miss.
Yeah. If you can recommend to your friends to take Mat 243 seriously and 310 seriously, yeah, do so.
Last question, problem set 0 on test.
We didn't even have our teacher.
Because we're all
Oh,
screwed now.
so I told some people here, but I have a funny story. So this shirt's pretty funny, huh? I was going. So at the final exam of last semester 355, I wore a shirt that said in big letters TA because I was a TA, and it said as a caption, "Ask me anything" with a star, and on the back it said, "Except if it's on the test, if it's in the syllabus." Yeah. So I mean, I know I'm inevitably getting questions like that, but not specifically that stuff. So anything from the first lecture until whatever we cover Monday. Yeah.
So basically, there's a loophole there, that if there is an induction group we may see an induction group.
Well, compared to what I probably will see as grades on problem set 0, I probably will or will not include that.
Okay.
Yeah.
Which they have like if we really need to learn more, or like depending on if like we got it, so it shouldn't be on there.
Yeah. So here's a major piece of advice. If you're gonna lose points, lose them on a homework. Don't lose them on the test. Okay? So that's why we put out solutions, so you don't miss points you missed before. Okay? So hopefully problem set 1 is not nearly as world-ending as I've heard it problem set 0 is. Seriously.
I feel depression.
Yeah. This class is hard, but it teaches you a lot about what fundamentally a computer scientist should be. Being able to reason formally about mathematical things, but also work with models of computation and how we can relate that to computation we really do care about. Yeah.
Now we out of here, here, change the subject. Can we do some GNFA conversions?
You mean NFA to...
GNFA.
Yeah, sure, no problem. Any other questions about problem set though?
Yes. I'm looking at the little section of what you have written back there, and I wasn't here for the first few minutes of class, but I've taken a similar approach to what I'm seeing at the bottom right, where I'm showing that there's some arbitrary element k that exists in xy, that exists in xy, it does exist in xy complement.
Well, what is XY here?
XY is it's problem set.
Well, something can't exist in a string as an element of a string. It can exist as an element of a set.
Oh, sorry. So it exists in the set of all strings xy.
X comma Y star, you mean?
Yeah.
Yeah. So okay, that's fine. Yeah.
Okay. But then in terms of like breaking that up into smaller building blocks that then we can like prove individually.
Yeah. So well, you're working with the language L. So you just assume that X and Y are in L. They're arbitrary elements of L. And then by induction, you say that they have the necessary property. Then does 1x, 0, y1 have the property also? So you assume that they're in L already. So you assume they have the property by induction. So does the thing at the end also have the property?
Okay.
It's just a proof by induction. Yeah. When you see the solution, you'll be like, oh, this is so easy. Yeah, I promise you. It's not hard, or it shouldn't be. But any other questions about problem set?
I mean, I was gonna ask about two.
Go ahead,
I'm still,
because this is more immediate. Yeah.
yeah, I'm just still really confused about that whole how to get the arbiter. I understand that we can do the tournament and then vertice and combine it with the second
Yeah.
one, but I don't understand how we're going to necessarily prove that there's either one or multiple or
Yeah.
a cycle.
So you'll prove that there's at least one hand path.
Yeah.
So therefore, there's either exactly one or at least two.
So how do we know that? That's the thing that
It-
I understand the funding
Yeah,
question. but,
you
like,
assume that there are two. If there are two, then give,
oh,
yeah.
Can we, so do we, for that problem, can we just, like, draw out examples and that would?
No. It says at the top, if you give examples, you'll get exactly 0. Examples aren't proof. The third question, second part of the first part, that is an example.
So,
Yeah.
so proof by exhaustion is fine,
No.
though. No? Damn it.
Well, exhaustion of what?
Oh, okay.
Well, they're
Proof, like,
because there are infinitely many graphs.
Okay, that's not what I was.
I mean, if you have infinitely much space, you could do it, I guess, but we don't have infinite space as far as we know.
So what I'm thinking, what you're trying to say is that for number 2, we would have to use definitions to prove.
For number 2?
Yeah,
For which part?
the graphing for,
No, which part of it?
at least one.
At least one?
Yeah, at least one or directed
That will be a proof by some word here.
by
On,
contradiction.
no, induction on what? The number of
Number of tiles.
vertices, thank you. Okay. Other questions? All right, so what was mentioned was, yeah. Ask questions earlier. Fine, it's fine. Yeah, it's fine.
What if the grid is populated by just any order?
I don't know what the question is, sorry.
6 with for the
Uh-huh.
number grid.
Yeah, so you can't assume anything about the entries in the grid other than the fact that they're positive integers.
Okay. And that's the integration exactly that number. So does that mean like I'm just 3 to 3 over? Does that mean?
Yeah, so if it happened to say, if we happen to see 3 right here, and then these could be like 1 or whatever, then if we happen to be in this cell right here, then we can either go down by 3, over by 3, left 3, up 3, or over 3 to here. And then if it happens to be too far, we wrap it around modulo style. Modulo. Other questions? Going once? No, it's not. But okay, so what was asked was NFA to regex style thing again. So let's do another example. Okay, so here's an NFA. So if I want to make a regular expression for this guy, what should I do? Yeah, new start state and what? New final state. Good. So new start state, epsilon my way in, and a single new final state, epsilon. Oh, that was the thing I tried to mention before. So a lot of people were saying that I understand the material as you're presenting it, and So that's a dangerous thing to, no, it's not a dangerous thing to understand me, but it's a dangerous thing to fall into a precedent that like, yeah, I understand what you said, so therefore I understand it. Working through examples and sample problems is really helpful. That's why I'm putting all those daily problems on Piazza so people are actually getting through exercises. Working through the exercises at the back of chapter 1 in CSE355, for example, that's also a great resource if you want to work through some problems.
Are those helpful for the problem sets as well, or just the
Both. All right, so we have these 3 states. So I'm going to make a copy of this thing. So what state should I remove? Or does it matter? Doesn't matter. Okay, well, yeah, other than the 2 that we made. Okay, let's start with the simple one. What one do you want? How about the bottom one? So how many transitions will I create? 2? 1. How many ways are there into that state? 1. How many ways out? 1. So what transition from what state to what state am I going to make? Yeah, the one right over here to where? To the original start state. On what regular expression? AB. Here's a great question. There's no self loop at that state that we're about to delete, right? What happened to it? And is it showing up in our regular expression AB? Yes, it is the empty string. What star is the empty string? Empty set. So I should be more formal. Yeah, go ahead.
before you added the new start state and new final state, what was the original final state, or does it matter what you're doing?
Yeah, so for the new final state, I make a transition from all the old final states to this new final state. So there happened to only be one, which was this guy right here. That was the only final state that was there. Yeah. All right, but empty set star is the empty string. So more formally, a GNFA is exactly as I defined it, and all undefined transitions have empty set on them. But I chose to leave that out because we didn't actually really need it. But that's the formal definition of a GNFA. All right, so we deleted one state. That's good. Are we done deleting states yet? No. Let's keep going. Paste. What state do you want to remove next? The original start state. Okay. How many transitions will I be adding? How many ways are there into that state from somewhere else? 2. 2. And how many ways out to somewhere else? 1. Okay, well, let's see. So if I'm going to be deleting this state right here, I better add the appropriate transitions. And what other transition am I going to add other than that one I just drew? The one on the right is a self loop now because it's going out and coming back. But since there's already a self loop there, I got a union with something. So let's do the one that goes overarching that I drew just now. What should be on that transition? B star is, well, formally it's epsilon, B star, epsilon, but we don't draw epsilons. We don't draw epsilons unless they're in unions. But for concatenations, anything concatenated with the empty string is the original thing. All right, we handle that guy. Then what else? Yeah, the second one. How do I go into the state I just deleted? Into AB. And then stay in that state, B star. And then out is epsilon. So then it's just, it's A, B, B star, and that's it. And then now we delete these guys. What state should I remove next? Only one. Yep, so I'm gonna copy this guy down, paste. So then this state's going bye-bye. So what transition am I gonna add from where to where? Start state to the final state. So from here to here. On what? So B star has to be there. So B star with what? Yeah, the whole thing on that self loop star. So I gotta put a parenthesis in. A union A B B star, whole thing star, and then what? Epsilon, but I'm not gonna concatenate. Yeah, and so therefore I've already done that. And then now I delete all this stuff. And so the regular expression I want is the thing on the transition. So it's B star, A union, A, B, B star, whole thing star. Yeah.
So I think the biggest problem I'm having is that I'm getting confused when I need to concatenate versus union.
Okay, great question. So, as I said, the hardest thing about this class is coming up with examples. All right, so let's suppose I have something that looks like this. Then this versus yeah, that's what I want. Now I'm going to put a character on it. So in both cases, I'm going to try to rip out the state in the middle. And then, therefore, in both cases, when I'm all done, I'm going to have a single transition. So what is the top one going to be? A concatenated with epsilon, which is A. What about the second one?
So that's the
AB union epsilon.
and that's because it's the ways that we could do the long path with the ways we could do the second path.
Yeah, but the more important thing that was implied by what he asked was, how come I was able to remove epsilon from the top one, but not the second one?
So you can concatenate, that is like the main difference, but the other one, like, if you don't include it, then you're not gonna include.
Yeah,
If that makes sense.
exactly. So if I concatenate the empty string, I'm just still going to get the original thing back. Whereas the thing on the bottom, that is completely different. It's saying that you could describe 0 characters, or you can describe 1 character. I'm not tacking them on together. So concatenating the empty string is much different than unioning with the empty string.
Okay, so that wasn't my original question.
Oh, I thought that's
what
what.
you drew actually helped me answer that question. My original question was, how do I know when I need to concatenate 2 different regular expressions on the transitions versus when I need a union?
Yeah. So whenever, yeah. So we're always doing a bunch of concatenations on here. So you're looking at all the ways into that rip state, then all the ways out. You'll concatenate the way in, and then anything on the self loop, then concatenate with the thing out. But if you have a direct way already there, so the transition already exists, then you will do union. But so formally, when I said that a GNFA actually has empty set on every single undefined transition, for this guy, there actually is a transition there on empty set. So this technically is a union empty set. But what is something union with the empty set? The original thing. So that's why we actually ignore all of this and go with a simpler idea. But it's still unionings happening all over the place and concatenations. It's just simpler to think of it, I think, this way. The formal definition will help with that when we talk about it on Friday. Yeah.
Basically, at the visible level, if there's multiple ways to go between two states, you want to union them.
Yes.
But if there's one way, but there's multiple states involved in that
Yeah.
one way, then you concatenate.
Yeah, because you're basically trying to simulate going through all that, and what you're doing is you're describing a string, then describing some more of it. Whereas with multiple ways to the state that you're trying to go to, you could take this way or this way. Okay, yeah, that was the idea.
Then my other question would be, why would it be wrong to say, instead of it being AB union epsilon, would it be wrong to say epsilon union AB?
They're the same thing.
That's what I thought, okay.
Yeah. Union doesn't discriminate on which order you put it in. Yeah. So, but concatenation is important because the order does matter there, but union does not matter order. Yeah.
So we always make a new final state when something is leaving the final state. And we always make it
Yeah. You have to do it if there is something leaving any final state, obviously. But even if there was, like in the one example from class, where where that state in the upper right that's in black was the only final state and had nothing coming out of it, I still recommend making a new final state and epsiloning it your way over because it's just purely algorithmic and it'll always work. You could leave that state there, but you just have more things to worry about in that case.
It only might work in some cases, or the other will work in all.
No, it'll always work if you have only a single final state and nothing leaving it. Then you technically don't have to add another state, but for this class, you always should put a new final state. Yeah, just so that it always works for any NFA, no matter what. Yeah.
So since we're learning it in very algorithmic way, are we expected to do that on the exam to be very algorithmic or to take shortcuts?
What did the back of my original shirt say? So that's a likely thing to, yeah. So I'm not going to make a huge, if I am going to, then it's not going to be terrible. Yeah. But if I am going to put it on the test or whatever, it'll always say using the methods in class. Yeah. So if you use the method from class, you'll get points. If you don't use the methods from class, you will not get the points. Pretty simple. Other questions? We still have 6 minutes, so we can hash out some other stuff. Yeah.
Can I ask you a question on 4? I don't
Yeah.
want to give away the answer, but so you're talking about the time complexity before, so big O v plus E.
V squared plus E squared.
Yeah, I know.
What
I
was
was asking about
yeah.
V plus E. General. Oh god. I thought it was going to go on forever. So in my 310 class that I took last semester, we were told we're allowed to change that to n because it's an arbitrary number of vertices, an arbitrary number of.
So the one, I'll stop you right there. The one thing I really, really hate about this department is that they confuse the formal notation of big O and everything. So they think like n is just this abstract thing. N is the size of your input, always, every time. Well, what is the size of a graph? However you present it. But the usual way is through an adjacency matrix, for example. But it won't matter here. So an adjacency matrix has V squared size. But if you had an arbitrary graph, maybe like through an adjacency list, for example, that would be, let's see, it'd be, I think E, roughly. I'm not sure, a constant times E. But it's not really important how the graph is inputted, but you can assume that a graph has V plus E size. So like
So
you have
don't-
V.
Write that on the board.
Yeah.
So
So
basically don't change it to 10, right? That's what you're saying?
no, you can, but you have to define that. So like this algorithm runs in order n. Well, what's n? Yeah. So like V plus E. So technically you should put vertical bars in these because V and E are sets. Yeah. So technically you should put that. That's the typical size of a graph. And you could say that that this is order E because the size of V is always at most. No, that's not necessarily true. No, I wouldn't say that. Yeah, I would just put V plus E.
That
And-
was-
Yeah, in a connected graph you can say stuff, but
And that's the size of the connected
in any graph,
graph, in any graph.
yeah,
And
because
vertices plus the number
yeah,
of edges.
yeah. So how would you do it? You would make V edgeless, and for each one you would put the edges. Well, at most you'll have two repeats of the same edge, so therefore it'll be a constant times E in that case. Yeah. Yeah. So this is what in the literature called linear in the size of the graph. Even though it's V squared at worst, because if it was a complete graph, then you would have every edge and you would have V squared of them. But this is called linear because it's when you describe algorithms, you describe it in terms of the size of the input. So if we actually get to the P versus NP stuff, which I really hope we do, we define the time complexity of an algorithm in terms of the size of the input. Instead of like some arbitrary abstract thing like n is, okay, I don't know what n is. This is precisely defined. Yeah. If you look at my videos from last summer on CSE355, we talked about this type of thing a lot, about like time complexity stuff. So if you're interested.
What's 294 for?
It was a topics class that's hopefully going to be turned into a real class called algorithmic problem solving. But it was an 8-week class, and I ran out of material within 2 weeks. So yeah, so I had to make material up. Well, no, not make it up, but like fine. Some people might have thought it was made up, but yeah, fun class though. Other questions? We still have a little bit of time. Or we can just awkwardly stand. Other question? If there are no other questions, well, I guess we could stop here. No other questions?
Are there any specific formatting for the homework? It has to be a PDF, but
Yeah, if we can read it.
okay. I mean,
Not me, but like if the grader can read it.
you want like the questions that are just to make sure it's legible.
Yeah, if we can read it, that's fine. Yeah. So the way to go about that is ask a friend if they can read it. Yeah.
There was you said you wanted 1 page per answer, or we have to specify. Can the answer go
Yeah.
over one?
So when you submit, you'll say, okay, this page correspond to question 1.
Okay. Thank you.
Yeah.
I
Yeah.
already filed this, I didn't file,
Yeah.
I told them I
Submit at least once so you can understand how Gradescope works. Okay.
There's issues with uploading PDF. If you cancel it, you can't cancel it, like overwrite it. It's kind of.
Yeah. When you submit, it overrides your last submission. Yeah.
And there's a problem where I uploaded, but there's no way to cancel an upload. You always have to go through the selection, or you go back to the main menu. If you go back to the main menu and it's still in the progress of uploading, it won't upload your second upload.
So you just have to wait for it to upload.
So you'll upload it, you can
Let-
upload your second one.
Let's see how it goes. If it goes terribly, then we'll switch back to Blackboard. I don't want to, but if it does, then we can certainly do that.
I just emailed them and they were happy for input, so.
Yeah.
If anything, you can just require page numbers for that. Yeah, because be like, oh, now we know it has to go. Like,
Yeah, but Gradescope sections them off when you grade, so it only displays the relevant pages to that question, the ones that you selected. So, I mean, you could go back, but it's more hassle.
Are
Yeah.
you splitting up the grading so one person only does one and then one person does consistent?
I can't say that, but each question will be read by exactly one person. So so it's not like split among people necessarily, but it's not like multiple people are reading question one. It's the same person for each
It's
question.
consistent
It's always consistent. That's the thing I hated so much about grading. It's consistent here. I promise.
Thanks for that.
Other questions? Good luck.
Thank you.
Yep.